All right. When we discussed the plans for the future meetings, I was asked to present something about how we use automation currently in the organization that I work for. Since I've made several presentations already for this community around using AI in testing, I decided to build upon it. And actually, earlier this month, I gave a talk as a part of a 4Q testing summit, where I gave an introduction to our approach that we used. And also, I have given some additional information about like how we use this approach and some additions for mapping, automatically mapping test cases to the requirements, because traceability is something that is usually required in the projects. So forgive me for using the presentation that has been ready-made for some other event, but here we are. So that was the original title. So the topic was the explainability for AI testing. And bear with me, I will try to explain why it is a challenge at all. So this is a high level structure of the presentation. So first I will share some thoughts about like how AI is and can be used in testing, what are the challenges, and how it is connected with the challenges of traceability and explainability, and just some vision that we share in our company, how we can use AI further to provide some mapping, some explainability for our tests. Okay, so this is like short information about the company I work for. So the key points that you have to know that first of all, we are a software testing company. So this is our core business, that we provide testing services. And the second important thing is that the sector we are working in, it is financial institutions. And more often, like if you look at our projects, so most commonly it is the projects that are connected to trading systems. So it's like most commonly it's exchanges. The starting point, usually in the presentations that I give, it is about software quality. And when we are speaking about quality, we are thinking about the platforms like as the ones that are delivering some value. And when we speak about the value that we provide to the clients, so it's not only the quality of the systems, but it also something associated with cost and speed. And of course, the problem is that everybody innovates right now. So if you take any organization in any sector, and everyone is speaking about AI, everyone is speaking about automation, and of course, we know that currently it's more and more innovation that depends on processing speeds and lots of available data. So all in all, the innovation is here, and it might sound like a good thing, but also any innovation is associated with a risk. So whenever we are speaking about something new, it is also like a huge risk, and this risk is also at the same huge scale as the automation itself. So, when we think about bringing value, we also should think about like the risk of decreasing the quality. And when we speak about the value that is delivered by software testing, we also should ask ourselves, like when we deliver our software testing projects, how can we do it like cheaper? How can we do it faster? And the problem with our domain, the domain that we are like servicing as a company, it is a huge complexity. So when we speak about trading platforms, it is huge complexity associated with lots of parameters, values, like lots of input data, very complex environments, lots of connected input and output systems. And lots of different protocols that we have to reconcile between each other. And of course, it's further exacerbated by the uncertainty that like human users present. So this scary picture, it is a typical structure of a trading platform. So this is a high-level overview so that you have like high-level understanding that how many components are there, so how many different connecting pieces are there, and what we have here on this slide on the right. So this is a funny picture that was created by our marketing department. It illustrates the Swiss cheese model. So Swiss cheese model, it is the schematic representation. So when we speak about complex technology platforms, usually they implement some risk tolerant mechanisms, and they do thorough testing for each of the components. And like exhaustive testing is not possible, so everyone knows that. But people usually try to implement several layers of defense. But still, sometimes this like there can be some condition where the risk factors align, and even if you have several layers of defense, there can be a single point of failure. So it can be so. So that's why we should use some very advanced techniques to cover as much as possible. And usually when people try to cover more with some approaches that are cheaper, faster, usually we are speaking about automation. So this next picture is about automation in software testing. So as all of you know, of course, software testing is a very technical process, and this process typically consists of several steps. First, we start with selecting some data. So we sit down and we think like what it is that I should test, like what is the data, what are these scenarios. So this is the first step. Then we have to actually execute the tests. Then we need to check the results, interpret the results, right? And then we have to adjust and repeat. So this is basically the simplified structure, the cycle of software testing. And if we think of automation, like related to this picture, related to this structure, like everyone is talking about test automation, of course. But if you think like what part of this automation process is really covered by real automation, so usually it is just a very one and very easy part, the mechanical part of when we inject the actual test into the system. So this is very easy, not in the way that it is so easy that can be done by everyone. But what I mean by easy, it is easily formalized. It is easier to automate, and this is something that we can automate naturally. And when it comes to something like coming up with a test case or analyzing and interpreting what we actually received as a result, so this is something of a more complex cognitive nature. And this is these are the parts that are much harder to automate. So And as I mentioned before, so when you work with really complex software systems, as your systems are under test, when you come up with a testing tool for those systems, the thing is that you can only effectively test those if your tool exceeds the system under test in complexity. So this is also something that we need to keep in mind. And given this mindset, this is a simplified schema of the approach our company is currently using to test. So sometimes we market that as a AI testing approach or data-driven approach. But if we define it in terms that are more or less traditional, in traditional testing, I would say that this approach is called model-based testing. So if you take a look at something that, like these funny cats in the center of this picture, so it is called again, like for the publicity, it is called digital twins. But what it is in reality, it is a set of Python scripts that we consider to be the model of the system under test. And the purpose of this set of scripts is to manage that automation part around different stages of software testing process. If you look at this part, at the upper part of the slide, you can see that the first step here is test basis and test basis analysis. So we extract some input actions like forgive me, I will be using the example from the domain. So I mentioned that it's trading systems. So for example, the input actions would be like sending an order to the exchange, to the trading platform. Also, protocol specifications. So if we look at the exchange, there may be several protocols that they use for communication. And we, for each protocol, we extract different types of messages and different parameters associated with those types of messages. And again, different types of values that are used for each of the parameters. And some reference data actions. So reference data, it is some information about the securities, about equities, stocks, that is not the prices. So prices is something that is changing real time, and it is called market data. But reference data, it is something that is more or less static. It is where the symbol is traded, like on which exchange it is listed, what are the round lots and tick sizes associated with that. So some information about that stock, like a dictionary type information. So it is what it is, and it doesn't change. So and it is something that we can use in our tests. So after that is analyzed. First step is to formalize it. Of course, we use specifications like I believe all of you do. Like most often, those specifications are in human readable form. But if we are talking about automation, this should be changed a little bit. So we extract the knowledge that is listed here, and we create the dictionaries within our testing tools where we list all those values, parameters, and everything that is needed for the model, like as a prep step. After that, we come up with some very, very typical and very basic behaviors around the subject domain. So we come up with some source test scripts. And after that, our model, our digital twin, goes through all the possible permutations, like depending on the situation, depending on the types of messages, depending on the valid and invalid values. And our scenarios are enriched. They are not only enriched with the values, but also they are randomly mixed and matched so that we do not just send one order with some combination of parameters, but we also send different sequences of orders of different types. And this is done randomly, and the possibilities are defined by the digital twin that is um, built with the test basis in mind. So this is kind of first step. Then we have the input data, right? But when we test, it's not usually the input data, right? We have to know. So we are not just running the test. We usually run it and we are expecting to receive something in response so that we can say, was it correct or was it incorrect? So for that, our model, our digital twin, comes up for the expected result for each of those tests. So we have a number of different other other scripts that calculate these expected results for us. So basically, this schema describes this process. So here we come up with the scenarios through permutations. Here we run those scenarios against the system under test. Here we, again, this is a line that is associated with the digital twin. We run our output data set through our model expectations. We get our interpretation data set that is enriched with annotations. And here we have weights data set that has information, statistical information about different data points, different code coverage criteria, and that helps us evaluate the test library in general, so that during the next iteration, so after step 6, we go back to step 1 and repeat everything. And here we refine our input so that it was more meaningful. So if the previous picture was confusing, here it is like more or less lean, I would say. So it just names the steps one after another. So this is basically our step-by-step approach to testing. This is basically the same that I just described in a long form. Okay, this approach with lots of steps can be really confusing, but let me speak a little bit about what are the main principles around this maybe too complex of an approach. So first of all, the main idea was to build a data-driven approach. And when I talk about data-driven approach, it is the possibility, the possibility to manage lots of data on every step of this process. So in this, and in particular, it is important so that the test execution data is separated from the model, the logic that creates the scenarios, the logic that creates the outputs, the logic that evaluates the test library. So it's everything is a separate element. And test tool that is used for injecting the data and capturing the traffic back from the system, it's also a separate element. And it's important that all three are independent and they're not connected, like in a strict sense, so that we can use every big chunk separately. So first of all, when we speak about test execution in this process, we need to target lots of tests at big speeds, just because like if you want to catch different edge cases, different combinations, different permutations, it is important that we really stress the system with those different scenarios. So we are not speaking about 5 scenarios, like 10 scenarios, it's thousands of scenarios. For that, we have we need to have a pretty performant tool. Then the model, as I mentioned, it is something that we use to generate tests, and it is something that we use for test results interpretation. So here a more detailed slide maybe. So we have the test basis. This is the process of permutation that I mentioned before, and this is a crucial step that is performed in order to arrive at our input data set. And another big chunk of the model is the digital twin part, which replicates the logic that we as testers conceived from the requirements. And after we like automated it in the form of Python scripts in our model, we can take the input data set and we can run those scripts against the input data set so that we have an expected outcomes data set. So maybe it sounds confusing, but what we actually send into the system under test, it's not the input data set, but it is the this ready-made expected outcomes data set that is injected already with the results, so that when the traffic is captured, we can compare one against the other. And this expected outcomes data set, it already has all the protocol data. So here we have just the logic of scenarios. So for example, I want to send an order and I want to trade another order against this one. So this is a simple scenario. Let's say I sent 100 shares for the symbol X at some price. So this is as simple as that. But what we have here, we have an instruction for the testing tool to send a message formatted in a specific protocol, having lots of fields, not only those that we discussed in our basic scenario, but also the fields that are that need to be present according to the specification. So all the headers, all the necessary fields, so everything. And right next to this message that is to be injected into the system, we have a message or 2 messages, sometimes 3 messages that we expect in response. So it all is in this big file that we create at this point. So this was the model. And the third element is the data. So the data is also, so I have emphasized that it should be separate. Why it should be separate? When we run our tests, we capture all the traffic, we capture the actual behavior of the system under test. And it might happen that after we look at this traffic and we are analyzing any discrepancies that our model might have detected, there can be a situation that we're looking and understanding, okay, here's the thing that I can see the discrepancy, and I looked and double-checked in the specification, and it turns out that the system is actually correct, but our model is not so much correct. So we need to refine it, we need to update it. So I can go into the code of the model, I can update it, and I do not need to stress the system again. Or, for example, like every exchange has a trading time, like from, let's say, 9:30 to 4 p.m., and I detect my discrepancy at 5 p.m. So I can take the separately stored traffic and run it again against the updated model. And in this case, I will have, as an output, I will have all the things passed. So just because I have like separately captured data, test execution data, and I have refined my model. So the this change is not necessarily requiring me to run my tests again against the system under test. I can use whatever I have captured previously. So, and if we speak about the data in relation to software testing, the data itself is very, very different. The data can be, first of all, of course, log files and traffic files from the system. So this is something that I have already mentioned. But also very interesting data, it is something from specification that we compile into our automated dictionaries. It is something, so it is tests themselves, right? So it's test injection data. It is the descriptions of the defects that we already know. Why it is important? It is important because client systems are live and they are constantly evolving. And if we today are testing some state of the system, and the next month, for example, the next release, they change this behavior, we can add it as a permutation, as something that can be different. So, for example, if today this description or this behavior in the system is indeed a bug, and the next time when we run our model against it, it is already fixed. So we need the possibility to switch it off and switch it on. Like for different releases, we can test the behavior of the system. So, for example, if we know that this bug is present in the system and we still need for the analysis to focus on something that we don't know, we can just allow the model not to highlight it as a discrepancy and just to go with it, so that we can focus on something that is important and still unknown. And some information about potential defects. This is something that is that we use to predict potential defect areas based on the weights of data points. Okay, so this is me speaking about the approach, the current approach, and how we tackle the automation nowadays. And as you can tell already, it is around. It is all about having lots of data. And when you have lots of data, like thousands of scenarios that were generated not by you manually, but by a machine through some permutations, and you as a tester like have to deal with all of those multiple scenarios, actually huge arrays of those scenarios, it is like there comes this scary point when the client comes and says, okay, you have thousands of scenarios, but can you please tell which of them cover which requirements? And here we need to quickly understand what is the real structure of our library, not from our model perspective, but from the perspective of our client. And this is kind of when the approach which seems like very fast and beneficial from the automation point of view, it starts to be very challenging. So it is indeed very challenging to trace the test scenarios back to system requirements, and when the question is phrased in an opposite manner, like, okay, I have the requirements, like which of them are covered, and I have this particular very complex test, what exactly what area does it target? So the two main perspectives. So and when we are providing testing as an information service, of course we have to take both of those perspectives into account. So the first one is the perspective of the software tester, who targets to find as many bugs as possible, and the other one is the perspective of test manager or the client, who wants to know like which of the business requirements are actually covered. So, and if we rephrase that, so the first perspective is that when we map our test cases to requirements, so we try to explain the test scenario, and the other perspective of the test manager, it is the coverage aspect, of course. So here it is a little bit. I don't know. I like this slide. Maybe it was just for the fun. So I like the approach like the understanding that the natural language requirements are something that inevitable in present based projects. So this is something that we all work with as humans. So this is the majority of organization processes that rely on human readable documentation. But at the same time, when we speak about automation, it's of course necessary to have something in machine readable form. So there is kind of a two-pronged approach that have to so that we have to employ so that we can map one to another. And if we ask ourselves, like, how do we even start to look into the automation process for mapping? So the answer is like maybe a boring one, the one that is actually always cited when people speak about machine learning, when they speak about artificial intelligence. So you just have to label everything. So label all the things. It is like all the like the only possible approach in the era of data-driven testing. So if you like start to look into automation on at a scale, so it is the only approach for you, like to if you want some explainability, like if you want some understanding what you actually have inside. So label all the things. So in our case, with the complex financial systems and with this complex model approach, what it is that we should label, what it is that we can label. Again, here's a little bit of philosophy. When the knowledge and the information in the world is like defined from the philosophical point of view, it can be divided into two main types: declarative information and procedural information. And when we translate what we can see in our system, like into this philosophical point of view, we can see that there are some parameters that describe the messages within the system or the states in the system, something that we can point our fingers at, like in our case with trading platforms, it is like, for example, action parameters that are available. For example, to send an order, to amend an order, to replace one order with the other, to cancel the order, to receive a trade, to I don't know, to carry out a must cancel procedure or something like that. So there is a certain finite set of actions that are available. There are parameters of those actions. There are areas, like functional areas, that we need to target. There are multiple components. There are multiple interfaces. So those can be considered as something that we can describe declaratively in the form of codex, dictionaries, and so on. And also there are some things that are that represent like events, maybe, or some dynamic things. And also we can annotate those. So if we look at the at how it is represented right now, we can see that the events, the description of what actually happened or is happening right now, it is something that we can receive through logs or traces of the actions in the system. But also we can try and annotate it. We can annotate it through the state transitions, and we can annotate it through adding some annotations to the code of our model. So as I mentioned before, we built a digital twin of the system under test. So it is a set of scripts, but those scripts, they describe some logic that the trading system operates through. And we do not have an access, like, I guess that most of you don't, and your projects as well. We don't have the access to the source code of the system under test itself. But when we come up with some model-based testing, we prepare those scripts that we think describe the exactly same behavior. So we have inside the model code, and we can annotate this model, and we can understand some, like, from those annotations, we can receive some picture of the of how the model is, like how far, how much it is covered. So maybe the explanation was a little bit vague. So here it is an example that I can give you. So for example, if we take a simple validation check for a message parameter and their value, so this would be a piece of code in one. So we have lots of components, lots of parts of the model, and this one, it is the simplest one that is connected to message parameters and their values. So for an order. So for example, if we take some particular check along with the outcomes of this check. So okay, don't focus on that because this is like system dependent, right? But what is interesting here, it is that along with that, we add a simple line of code that just goes when our test scenario is triggered, and when this test scenario triggers the model to go through this code, through this if loop, we just add the annotation to our logs, to our traces of the logs. So, and it is human readable annotation. It is a human readable annotation. And after that, when we work with the data afterwards, so we can download it as a statistics file, and the line of interest for us in this the statistics table would contain slide. This line in this statistics table will contain the validation script that was run through this test. It will contain our annotation, so the one that we were targeting in this code. And the thing is that it is very rare that when a test script triggers some model code, that it triggers just one thing. Sometimes it is some other parameters of the event as well, but it is presented in the statistics as a whole. So we can actually see after all the tests run, we can see the whole huge list of those annotations with the test cases count associated with all of them. And we can see, okay, so if we trigger this particular annotation, so something that in this case in like an invalid value for a tag of order quantity is being sent. So we can see that there are 3 test cases that that are mixed and matched in our test library, but there are 3 of those that have exactly this annotation. So this is a limit order that was sent to the exchange with the time of force day, and this order was on the sell side, and someone failed to enter a correct value in this order. So this is what happened. And here we can see like all the events of such a nature, and we can trace it back to the test scenario. We can trace it back to the requirements, and we consider it to be very useful for our next step. So what you can see on the left, this is more or less something that is already done. So we have tests, we have some annotation process that we utilize like on different levels for parameters, for actions, for matching engines logic, so for everything. And our next step, so we have those human readable annotations, we have human readable system specifications, and we need to map one to the other. So what our developers are currently working on, it is like employing that this approach, the approach of, so they're thinking about combining large language models with some traditional approaches of vectorized representations. So we really hopeful that this vision will be will see the world really soon. But what we can tell at this point is that when we speak about software testing, software testing of complex systems, we should expect the tool to be equally sophisticated. When we speak about AI-driven testing, it's most likely would be model-based testing. So usually you will have some model that that works with expectations at a scale. Also, test data is a separate entity. It is an independent entity and can and should be managed as a data set. and it's preferable that it can be isolated from test execution and test and system modeling parts, just because of the maybe cost and resource considerations, because lots of scenarios, a very big test library, it is something that is usually hard to execute. So, in my project, the huge test library consisting of about 4,000 scenarios, and it is run really quickly, so maybe couple of minutes, but it is being checked and analyzed like for 20 minutes. So usually, like to save resources, you have to manage it separately. So it is a good idea to keep it separately. The next one is the challenge around traceability and explainability. And when we try to address this challenge, it's better be done through extensive labeling. As for the process of the labeling, it can be applied to something that we have as facts and something that we have as events, like declarative and procedural knowledge from the system under test. And we can map it to our test artifacts, and we can map it to the human readable documentation. So this is more or less it. Thank you. Thank you. If you have any questions, or we can have it as a discussion point, maybe we can do that now.
This is very good. Very interesting. Model-based testing is definitely something I have no experience with, but very interesting.
Mm-hmm.
I am curious, you're talking like, what, 4,000 scenarios that you're running?
Well, that's a particular project,
Right.
and it is really different, like from project to project. So this is something that I'm running on daily basis. If I count everything that I have in my repository, it would be around around 100,000 scenarios. Just because it takes time. Like you develop a scenario, you commit it to GitLab, and then you analyze the behavior, you adjust this scenario, and maybe you add more permutations, like on the human stage, even before that permutation that is done by the model, by the machine. So, and the library is constantly growing and growing and growing.
So what I'm curious about is if you're running thousands of scenarios, you're getting results back.
Yeah.
Of the results, how, like percentage-wise, how many are legitimate issues with the product, and how much ends up being noise or issues with just the model itself compared to actual bugs?
Well, first of all, I wouldn't call that a noise when we have just the discrepancy between the model and the system. So every discrepancy is very interesting. And whenever we have this, it's a separate like line of task. We have like developers like to constantly update our model. So it is really necessary to go and update that, so that when a new release comes, we can compare it and for those discrepancies to go away, like so that we have the real data. Also, like I wouldn't say that we have real noise there. So what I'm working currently with, it is a project where we've been like for a year and a half. So it's not a project where I stumble upon like real bugs. So it's basically further and deeper investigation of the system under test. And it's more likely more about finding some edge cases, finding something that is not that evident.
Hmm.
So the evident things have already been tested. So it's about finding edge cases, I would say. So my most recent bugs were all about specification, actually, just because I noticed something in the behavior of the system under test. And I got back to the client, and we sit together and we understand that actually it is expected behavior, but yes, it could have been phrased a little bit better in the requirements. So it's very interesting things that can only be caught with like very unusual combinations, let's say so. So they even didn't think about it when they wrote this specification, just because human user will never do that. Some of those are like just stupid human mistakes. So it's not only model. Like recently, I was thinking about adding a permutation and was sloppy enough to enter an extra space to the field which actually accepts space as a valid value. But so it can have several values separated by space. But I was sloppy and ended it with space. And this is an invalid combination.
Mm.
Yeah. So I'm very proud of this sloppiness because this is where I outsmarted our model. So even that didn't come up with such a silly thing.
Miriam, you have a question?
Yes, thank you, Elena, for this excellent presentation, and thank you, Tony, for organizing this meetup. Yes, I wanted to ask Elena, did you use for the model? Did you use a pre-trained model, or you created a model from scratch?
From scratch. From scratch, and it is just to like avoid implications. So the model that I was referring to, like for the basic approach, it is not an LLM. It is not the Gen AI model. It is the model that combines traditional machine learning with a more formal rule-based approach. So it is not everywhere that we use AI and machine learning, because some things have to be like they're called discriminative, like as opposed to generative things. So we have, for example, like some validation checks, they are rule-based. So I had an example on one of my slides. So this is like a perfectly traditional rule-based approach of formalized rules, like and validation checks. So this is the place where there cannot be like any uncertainty, right? But there are things that like can be subjected to the AI approaches, and this is when we, as I mentioned, have lots of annotations. We have lots of data points. We annotate everything, but of course, if we have huge number of annotations and huge number of test cases with those annotations, sometimes it's just impossible to understand what is what. So, and when we come up with a good test library with like meaningful combinations of the data points, we need to utilize the mechanisms that would assess each test case, like based on the annotations that are assigned to it. So, and based on the weights assigned to every annotation, like whether it's worthy of being included into the library or not. So this is the part where, yes, we use machine learning. Also, I do not use it in my project, but I know that for some other projects, we use an approach when we use AI, like decision-making decision trees, when we run the system traffic against the machine learning algorithm, and the machine learning algorithm comes up with the code for our digital twin, and it tells like what ifs should end with what outcomes. Like it basically writes, like proposes the decision tree, the code structure for our digital twin, like to describe a particular part of the model. So this is also one of the good applications of machine learning. But speaking about like the rule-based mechanism inside, it is written from scratch.
Okay, thank you. And for the database for the model training, did you use internal database or an open source or an open source database? Because you know, with the ethical consideration and
So internally, like for storage, we use Cassandra database. Like we have our own data lake, but it is based on Cassandra database. As for the approach to data structures, our approach is to keep the data as simple as possible. So our main format is CSV. So this is the format that we use for human readable scenarios. For the basic scenarios that have just steps and parameters, and for the injection messages, it's also CSVs. We inject them through the tool, and it is only on the tool level that so the tool consumes this CSV scenario that a human person can read, and the tool converts it into JSON format or in whatever format it is used for, like the actual system under test. So it is managed all by the automation tool. But we as people and we as data analysts, we store it in CSV form. So that the scripts, so the data analysis scripts, so you heard probably that most commonly it's used, so it's processed either in R language or in Python. So we use, at our company, we use Python for that. So Python is not very quick, but we can afford like it analyzing, running through CSV files because they are in human readable form, and it can be done. But for the injection purposes, for the execution purposes, it is crucial that we use other programming languages that are faster. So the injection tool is really separate from the data analysis tool.
Okay, so you have your own database for the training. You had your own data set.
Yes.
And okay. Thank you very much for answering my questions.
KJ, you got a question?
Yeah, I was definitely wondering how we could connect. I could connect with you guys. You definitely want to take some time to review the video. I definitely want to make sure. Do you guys have? I see that there's like a Ministry of Testing website. Yep. Do I join that? Create an account there, and is there like a Discord or like Slack I could join as well?
There is a Slack available for paid members, but we have a meetup page as well. And you can communicate through there.
There's also a group in LinkedIn for the ministry, for this, for our specific Ministry of Testing group. Let me drop a link to that in the chat too. Right now it's very quiet, but I'd love to see people start chatting there more.
Yeah, definitely. I'm looking. It's important for me to try to obtain an AI solution to the things that we have to do. So, I'll definitely looking forward to kind of chatting there. So, thank you.
Any other questions? All right. Great job, Elena.
Thank you. Thank you so much.
So it looked like Shiva joined too. Did I see you pop in?
Hi, Karan. Shiva here.
Are you still able to present next month on API testing?
I would definitely, but yeah, I can do that. But I just want to ask the all the community members here, like what I would like to, like you like to listen about, like do you want a kind of a refresh of the Postman or any specific set of like the functionality. At the moment, I don't have a provision of like using my organizations, but I can still use something from like the common portal what I have to explain the stuff. But definitely, but I just like to understand from every one of you, like what would be the best, or you guys can suggest me what you want. So yeah.
Does
I mean,
anyone have thoughts on that? Oh, sorry, Tony.
I was say I'm open myself to just about anything, but I've used Postman quite a bit.
Sure.
But it's been a few years, so
Sure.
would not mind starting from the beginning either.
I can understand. I think okay. I'll just try to touch base with the set of the flow on the testing aspects, right? Like I'll just list on the topics what I would be covering, and hope my details, like is it Carolyn? Is it mentioned at the next meetup that I would be presenting? Yeah.
Yes.
Okay. Okay. APS strategy. Okay, Chris. I'll definitely do something of like other continuous flow. I'll do more often, but I'll just design a flow and whatever I can cover in the upcoming, and the rest I will definitely continue as and when it is free slot. Then I will do it. Yeah.
Sounds great.
Thanks,
Thank you.
Caroline, for asking. Yeah, and I'll just look for the details and I'll just update you, Tony and Caroline, on that.
Okay.
You guys can take a look and suggest me with your thoughts. Definitely, I will do my best. Yeah.
Great. I'm also looking to have Jenna Charlton come. I don't know if you guys are familiar with them.